Okay, so now we're going to apply this idea of GCF, and now we're going to do it with monomial expressions. Remember, the word monomial means connected by multiplication. What we want to do is look at our monomial expressions and find out what's the greatest or largest value we can divide both of them by that's the same. Now, because we're dealing with an algebra expression, not only are we looking at the coefficients, the numbers now that we can divide by, we're also looking at the variables. So when we do a GCF of an algebra expression, the GCF can be a number, it could be a variable, or it could be a product of the number and the variable. So let's look at our PowerPoint at our example. Suppose I want to find the GCF of the expressions, the monomials, 14x squared and 35x to the fifth. Okay, they're both monomials. They're connected by multiplication. Well, technically, we could do the same thing that we just did a minute ago with numbers. We can make the list of all the factors. So we'd first start with the coefficient. So in 14x squared, the coefficient is 14. So let's think, what are our numbers that multiply to 14? Well, it's 1 and 14 and 2 and 7. And I'll list those in numerical order. 1, 2, 7, 14. Okay? Then we'll look at our variable x squared. Well, we already know what x squared means. The only way you can make the term x squared is to multiply x times x. So that would be the factors of x squared. It would be x times x. Okay? Now we'll go to our second monomial, 35x to the fifth. So remember, it's a monomial. It's connected by multiplication. I'm trying to find the GCF, which means I'm trying to first get my factors. So let's start with the coefficient 35. What are our factors of 35? What multiplies to 35? Well, it's 1 and 35, and then it's 5 and 7, and that's it. Okay, so in numerical order, I'd have 1, 5, 7, 35. Then I have my variable x to the fifth. Now, what does that mean when we write x to the fifth? Well, we've been talking about it all semester now. X to the fifth means I have x's multiplied 5 times. So if I broke down x to the fifth, it would be x times x times x times x times x. Y'all with me? Great. Now, our goal is to get the GCF. What's the greatest common factor those two terms have the same? Well, if you look at the list at the numbers, both 14 and 35 both have in common a 7. 14 can be divided by 7. 35 can be divided by 7. So the GCF of 14 and 35 is 7. That's the biggest number they have in common. But now we'll look at the variables. We had x squared that meant 2 x's. We had x to the fifth that had 5 x's. We're asking for the GCF. What's the greatest amount they both have in common? Now here's the boo-boo. You guys hear the word greatest and you think, oh, it's x to the fifth. That's the greatest term. That's not what I'm asking. I'm asking you to have x squared, which has 2 x's, and x to the fifth that has 5 x's. What's the most they have in common? And if you look, the most they have in common is 2 x's. And x times x is x squared. So look at me. Think about it in real life. If I had $2 and you had $5 and we both wanted to give the same amount to charity, say the Salvation Army was ringing their bell at Christmas. So I have $2 and you have $5, but we want to give the same amount. Could we both give 5? No, because I don't have $5. Could we both give 2? Yes, I have $2, and if you have 5, you could surely give 2. So the rule is, in algebra, the GCF of a variable is not the term with the biggest exponent, it's the opposite. It's the term with the smallest exponent. So yes, you can find the GCF of an algebra expression by doing no work at all, just looking. The first part you would look is the coefficient. So you would say, okay, I have a 14 and a 35. What's the largest number I can divide them by? Oh, that's 7. Then you'd look at the variables, x squared and x to the fifth. And when I ask you the GCF, you always take the smaller exponent. So you would take the x squared. So that's why your GCF is 7x squared. All right, we're going to try some on the board. I'll see you in a few.